Okay, so in the last class, we've discussed that 8254 modes are very important. They are quite graphical in nature, so we need to study them separately and then we'll be seeing their application on the basis of the operation of the modes. That modes will be studying today. So basically, there are six number of modes in 8254, and all of them has a unique waveform which will be coming out in the output. So that waveform is the output waveform is what we are looking to draw in this. So as we have already seen, the output will be coming out from the counter, either counter 0, counter 1, counter 2. Every counter has two inputs. One is clock, which will be always connected, and one will be the gate. That will play the role in designing everything. Okay then, so let's start with mode number 1. So the first mode is called mode 0. Fine, and the name of this is interrupt on terminal count. In short, I call this thing ITC. So mode 0, the first mode, is called ITC. So in order to understand this mode, there are few waveforms we need to draw. So first one I'm drawing, rest we can follow a little same phenomena for 2 3 things. So first thing is one thing which will be always connected, that is your clock. Fine. So clock we can draw like this. So this is how the clock can be drawn. So after clock, what we need to draw is, or what we need to understand is, every counter is having the count. Count means how many times the counter will operate, or just like a loop, how many times the loop will operate. Okay, so this count will be a physical value. Let's say n is the value. Fine. And when we are deciding a value, where that value will be written inside, so the control signal that will be generated is the right signal. So the count will be written inside the counter. Okay, so control register or the control signal that will be generating is WR bar. All right, so it is an active low signal. You can see there is a bar on top, so it will take a single pulse as a low pulse. So this is the place where your count will be loaded inside the system. Okay, so let's say I load a count value. Let's start with a very small value, n is equal to 4. On the basis of this, our output will come. Okay, so what happens in this ITC, interrupt on terminal count mode? Let me show you the output. Okay, sorry for the disturbance. So the output of this particular mode, how it will come and how this mode works, this is just what we need to understand. So I told you the counter works here in the phenomena of down counting. So how it is going to operate in this particular mode, see. You better draw these things parallelly the way I'm drawing, otherwise you will not understand that. So what happens is once the 4, which is your count value, it has been loaded. So at every pulse, you can do a little marking. That value will be having some operation. So what's going to happen? Firstly, it will be loaded 4 as it is. Next pulse, it will be decremented, so it will become 3. Next pulse, it will be decremented again. Then it will be decremented again, and finally we will be having the 0 value at this particular pulse. So this is what we call ITC. This is the place where we are having the terminal count. Terminal count means the last value. Okay, so in order to generate the output, or in order to take care of the output, we need to understand few things. We need to take care of one thing. What is that one thing? That what is the previous state of the output. We will be drawing it, but we will be continuing from the previous state. So we have to take care of the previous state of the output pulse. So in order to remember that, it is very simple. Just remember by the mode. What is the mode we are having? We are having the mode 0. Fine. So initially here output will also be 0. Just remember from this mode number, mode 0, and the output will initially be 0, and it will remain low. The output will remain low until and unless we are getting the edge of the terminal count, which is your 0 value. So this is the output of your mode 0 when it will be operational. Is that clear? Is that clear, everyone? Okay then, but this waveform is not having any effect of the gate. We have to show the effect of gate also. Fine. So what happens if gate turns out low in between? Because the gate has to be 1 always. Then only the counter will be operating. Because if you remember the block diagram we have seen, every counter is having 2 inputs. One input is gate, which will be always connected. One input is your clock, which will be always connected. Other input is your gate, which can be switched, and finally your output. There are 3 terminals in the counters. So clock we have connected, it will be always connected. Output we have seen, this is without gate. The output we have seen is without gate. This is just for you to understand. So we have supposed that gate is always 1 during the operation. So let's say during this particular time the gate turns itself low, alright, for this duration. So now what will happen to the output waveform? How the output waveform will be changing its shape? Fine. So because there is something, this gate turns itself low. It is not required, but somehow it happened. So when this thing happens, the gate turns itself to low, what will happen to the output waveform? Let's see that. So what was the original phenomena we were having? 4 minus 1 3 minus 1 2 1 0. This was the original phenomena we were having. Since at this point of time the gate is low, that means your counter will not be operational. If counter is not operational, this means it will not be doing the decrement. It's not even working. All right. So what is going to happen? 4, and we were supposed that 3 should be here, but since it is not working, it will have the 4 as it is. Next, when at this point of time when a counter is activated back, it will start operating like this, -1, then again -1, and then -1 at this point of time. So what happens here is, till the time gate is low, the counter will not be operational. It will not be doing what it is supposed to do. That is your decrement part. Fine. So how the output waveform will change? So initially output is low. Earlier it was at this point, but now it has been shifted by one pulse. So see, this is the change we are having in the output when gate is low at any point of time within the operation. So is that understood? All of you, is that understood?
Yes, sir.
Great. So this is your mode 0, which is called interrupt on terminal count. So in a pulse is getting generated at the end of the terminal count. Fine. So next we will see mode 1. In all the modes, you need to draw the waveform like this. The clock will always be connected, and there will be a right pulse that will always be connected. So next we have is mode 1, and mode 1 is called Programmable One Shot. Programmable One Shot. Okay. So what is one shot? I'll let you know. What is one shot? So same clock pulse, right pulse, right. So this is where your count will be loaded. Let's take the same count. So what is one shot means? One shot means a single pulse of a one state. Okay, but it is having different shapes on both sides. Now, what does that mean is, if it is low pulse, so when it will be called one shot, when it is governed by high pulse on the both sides. Okay, or vice versa, when it is high pulse, their edges on the different side is called one shot. So there is a single shot having of single level, whether it is low level or high level, or low logic or high level. Fine. So this is the kind of output we'll be having. So we have drawn the clock, we have drawn the right, we have loaded the count. So let's see the output, how it is going to be. So whenever we talk about output, we need to take care of the previous state of the output. So likewise, in mode 0, the previous state of output was 0. Take the same approach. This one, mode 1, now we are working for mode 1. The initial output state will be high. It will be 1. Alright. So what will happen to the output in this case? So we need to take care of the counting fashion again. How this counting will be done in this pulse? It will be same 4, 3, 2, 1, and next is your 0. Alright then, so what is going to happen here is the output waveform will be acting, initially it will be high, and when it turns itself low, it will turn itself to low at this point when the count is getting loaded, and it will remain low. It will remain low till 0. So that particular thing is called one shot. There is a single shot. Okay, that's why this thing is called programmable one shot. Now, why we call this thing programmable? But because the length of the shot depends on the value of count, and the value of count can be programmed. We can change this value. We can have any kind of number. Okay, so this particular thing is called shot. Now, what will happen to the gate if there is a change in the gate? So this particular thing is very important. You can mark it like a star. So if I say let's do it again at the same spot, gate is initially high, but somehow in between the gate turns itself to low. So what will happen to the output of this now? So what was our earlier uh, fashion of decrement 4 3 2 1? It was like that. But in that case, what is going to happen is there is a different phenomena. The phenomena says the moment the gate pulse turns itself to low, the same moment at this point of time, your count will be reload. So at this point of time, if any point of time it becomes low, the gate turns itself to low, and when it becomes high, the count will be reloaded. So now at this point of time, it is having the new count value. Fine. Now the same fashion will be repeated, like 4 3 2 1, and this is yeah 0. So how the output will be changed? There will be a changed output. Now you can see initially the output is 1. It will turn itself low now, but it will remain low for a longer period now. The length of the single shot has been increased. So this is the change we will be having in the output when gate is low during the mode 1. Is it clear? Is it clear, everyone?
Yes, sir.
Yes, sir. Yes, sir.
Anybody having any doubt? Although I'm trying to keep it very simple, otherwise you will, once you see these waveforms in your notebooks or in your books, you will be very surprised to what to draw and what not to draw. Okay, is that okay? The way we are doing it?
Yes, sir.
Yes, sir.
So, better. Okay, then let's come to the mode 3, that is your mode 2 rate generator. We call that rate generator. Same thing, clock again, right pulse again. So this time we need to understand what do I know about the rate. So how do we define rate? Can anyone tell me? What should we get from the rate? The moment we hear that there is a rate of something. So what rate word tells us?
The occurring of anything each second.
Occurrence of something at every second. All right. Anything else? Anyone? Okay. So somebody said occurrence and reoccurrence. That is perfectly fine, but with a change, because rate signifies the change. Occurrence with a change. All right. So whenever we see a rate, that means there will be occurrence or there will be reoccurrence of something, but with a change. So that is the same thing we are having here. And all right, let's draw the output. So in this case, let's load the count again. Let's have the same value 4, and now let's draw the output, how this output is going to be. So same thing, we need to understand first what is going to be the initial form of the output or previous form of the output. In this case it will be high. again. Okay, so how these things are going to work in this particular mode? See, same pattern of decrement, 4, 3, 2, 1 and 0. Fine, but what change are we going to have? What is that change thing we are going to have? Now, just I'm drawing the waveform. Just tell me what is that thing you are getting from this waveform. So what just happened? Can anyone tell me how this what this output is telling us? Anyone? That change, what we were saying, the output is changing when your terminal count is 0 and it will remain low for the period of 1 pulse or 1 t at the time of terminal value. So this is what we call the rate. Fine. And the moment you are having a question, the way it will be written in your exams, the moment mode 2 will be applied in your output, they have a different way of asking it. So sometimes they ask you like generate a pulse. So what is going to happen? Just try to understand the output waveform, because this is what is going to help you identify which mode to fit in. Okay, so when somebody is asking you to generate a pulse, now try to understand where is the pulse. This is the pulse. This is a pulse. A pulse needs a proper change: high, low, low, high. Fine. So that proper sequence of change defines you a pulse. So this is a single pulse of low. Single pulse of low. Fine. So that is what we call rate. Okay. Now what happens next in this is 1, 2, 3, 4. After that, the count will be reloaded. At this point of time, the count, this 4 count will be reloaded at this point of time. And how it will be reloaded? It will be reloaded in a fashion 3. It will start from 3 now. 4, 4 minus 1, 3. So next what we have is 2, 1, 0. So now the output will behave in such a way that it will again go 0 where the terminal value is having. So again it will go like this: 2, 1, 0, 1, 0. It will go like this. So this single pulse is reoccurring. Single pulse is reoccurring with a change. What is the change? The change value of the count. So that's why we call this thing the rate generator. Is that clear? Is that clear? Any
Yes,
doubt?
sir.
सिर्फ इतना याद रखो, there is a change and there is a reoccurrence of a pulse, single pulse. That's it. And how they ask you? They ask you in same question, generate a pulse. So whenever they are asking a generate a pulse, your mode is mode 2. Okay. So let's get back to mode 2, mode 3 quickly. It is very important and it can be done very quickly. Mode 3 is your square wave generator. Mode 3 is square wave generator. Fine. So whenever somebody, it is simple. They are asking you to generate a square wave. Mode 3, just fit in, no other question. So we have same clock pulse, then right pulse. Okay. Let's say I write n is equal to 4. Now in that case, square wave. It is mandatory. It is mandatory to have gate hardwired. Do you understand hardwired? Software means the programming, and hardwired means the connecting physically. You have a wire which is soldered to some potential. So gate should be hardwired to 1, because if gate is low anytime, there will not be any square wave, it will become rectangular wave. Okay, because the shapes we need to maintain. How do we define a square wave? Can anyone tell me? How do we define a square wave? Anyone?
Sir, equal in
Equality in what? What? Quick. This is very simple concept. Very simple. Any wave which is having two things. Two things are called T on, which is called on time. On time is when it is high or it is having 1. The level is 1. And T off is the off time. Off time means when it is low. Fine. So if T on is equal to T off, that wave is called your square wave. If T on, the on time, this is your on time, and this is your off time. Alright, if on time and off time are equal, this is called a square wave. Alright, is that clear? So
okay, sir.
in that phenomena, the output waveform will be a little different. It is not same like the previous ones. The output waveform will be a little different. So how the output will be created? Because in this the decrement will not be -1, but in this case the decrement will be -2 -2. You have to understand a little. Right, so initially it will be low. Initially it will be low. So how things will be telling you how to change the stuff is like this: 4 -2, 2, 2 -2, 0. Whenever 0 comes, the count will be reloaded automatically. So how these things will be operating? It will be operating like this: 4 2 4 2 4 2. Now how to draw this thing? This like this and like this, and it will go on. So you can see by yourself, the on time and off time, they both are same. If anything happens in between, gate turns itself to low, it will change the on time and off time. Fine, so it will not be a square wave. But the problem we are having here, we are having a different kind of problem here. The problem is this count value. The count value will not always be what we have here, the even. Fine, it can also be odd value. So what we'll be doing when we are having the odd value of count? Let's say the n is equal to 5. Fine, so in that case, when we are having this kind of problem, what they have devised in the case of count, and count is having the odd value. Fine, so in this case, T on will be n plus 1 by 2, and T off will be n minus 1 by 2. So how many n, what is the value of n we are having? 5 plus 1, that is 6 by 2, that means 3, and T off will be 5 minus 1 by 2, that is your 4 by 2, 2. So this case, T on will be 3 pulses, and T off will be having 2 pulses. This is not exactly a square wave. This is not the definition of square wave. This is a rectangular wave. So this square wave mode is having a little problem. What problem we are having? In case you are having an odd count, try to make it even, because plus 1 at this point of time will not make a difference rather than in the end. If you are having an odd count at this point of time, try to make it, because at least we will be having a shape that this thing is called square. Fine, otherwise it will always be the rectangular waveform. Alright, so how this output will be if we have this case 5 4 2, then 4 2. So it will remain on for 3 pulses and it will remain low for 2 pulses. On for 3. So this is a T on, T off. They both are different. It is a rectangular wave. This one is good. So my personal advice is, if you are calculating the count for square wave, try to keep it even. Try to keep it even. Alright. Is that clear, everyone? All the modes we have discussed?